So, autoionization. That's when water, two waters, come together and one water grabs another or grabs a proton from the other water and now makes hydroxide and hydronium. All right? That's what water does on its own, autoionization. It doesn't do it at really high concentrations. It doesn't turn the water into an acid or a base, but it's there. It's an equilibrium that's established in water already. So a definition is water into hydroxide and hydronium. That's my definition. The equation is 2H2O liquid makes H3O plus aqueous plus OH negative. That's the equation. A visual is OH H H. All right. Now, since this is an equilibrium reaction, I can write a equilibrium expression for it, K, and it's only going to be dependent upon the amount of hydronium and the amount of hydroxide, because it's the only this is a liquid and they don't go into the equilibrium equation. Now, it is given a specific title called Kw, and you'll notice on our cheat sheet or our reference sheet, it's there. It's given to you. All right. They don't do it in terms of hydronium. They just do H plus, and at 25 degrees Celsius, Kw is equal to 1 times 10 to the negative 14th. All right. 1.0 times 10 to the negative 14th. All right. Now K will change, but it'll be given to you, and this relationship is going to be pretty important in terms of using pH and solving for pH and different concentrations. All right. Now, there is like a really important formula box that I got from a woman in Tennessee. I feel kind of cool saying that. Uh, Here's the formula: Kw equals concentration of hydronium and hydroxide. That's the formula. All right. Now, H3O plus concentration is equal to Kw divided by your concentration of OH negative. All right. And this is the concentration of OH negative is equal to Kw divided by H3O plus. All right. So this formula, if you know if you know either of your concentrations of hydronium or hydroxide, will allow you to calculate the other one. And I'm leaving this Kw as a variable and not a value because it can change dependent upon the value of the temperature of water. Now, uh, put here your pH, and over here you're going to put your pOH, and and then I'm going to spin the paper. pH is equal to the negative log concentration H3O plus, all right? And your concentration of H3O plus is equal to 10 negative power pH. All right, and this is it should be a capital H. All right, so if I know the concentration of hydronium, I can figure out my pH and vice versa. All right, and the same thing goes for your POH. POH is equal to the negative log concentration of hydroxide, and the concentration of hydroxide is equal to the 10 raised to the negative POH. All right? Now, these two formulas, pH plus POH equals 14. All right? So to go from here to here or vice versa, 14 minus pH equals POH, and 14 minus POH equals pH. All right? And that is like a formula box. There's like 12 formulas in there. Or actually, no, not 12, 10. All right? And it's all basically coming from the fact that all of it comes from this formula, all right, where those are the concentrations, and they use that to figure out like the pH scale, the log scale for pH. All right.